HPDMA is there. So that this will be helpful to them. So if our DME is neither installed with DVR nor with ILS, so which we have not installed in recent time in RCDU. But if it is there, then as we know that there is this DME is installed with DVR or ILS. So this DVR and ILS sighting criteria will cover those DMEs. But if it is installed standalone, so we have to make sure that there is no constructions within a circle of 150 meters. And beyond 150 meters, no structure should go above the 3 degree. By 3 degree means tangent, tan theta. So if my DME is this, if my DME is this, and this is 150 degree circle. So this is front view, not top view. This is front view. So any structure, these structures can not protrude an angle of 3 degrees. So 3 degrees se upar, this 3 degree, no structure should be there. This is the basic sighting selection criteria for DME. Okay. Somebody's audio is echoing. So if any question, then okay. I think somebody audio is echoing. Please switch off your mic.
CNIC Kandla.
Okay. So first, this physical installation, what we will be covering basically is it is very important, especially for the stations where this DME is about to install. So this plinth fixing. So this plinth fixing. The next is earthing system involved with DME. This earthing system. Then we'll discuss the antenna installation of DME. Then whatever the RF cable is required between equipment and antenna, we will lay that as well. And, inside the shelter, there will be equipment installation, and if any interconnections cables are there. Can you switch off your mic? Pankaj sir.
CNSIC Kandla. Sir, are you hearing me? Sir, kindly mute yourself, please. Piyush, you may continue. I'll call him on phone. Okay.
Okay, so we will go through these one by one. So this first one is plinth fixing. Here, these are a few images of DME plinth. So on the left, as you can see, this is not standard, so don't take it as reference. Particular drawings for these plinth will be. I will share you the drawing also. So here you can see this is supplied with equipment. These boards, these are supplied with equipment. So here, as we can see, this is a sort of a temporary template which station has made, because there was this template is not provided with this current DMEs. Only these bolts are provided. So this can be very little tricky, and because some station civil people asked for the template itself. So if template is not there, then there might be little confusion with CNS also. So here this bolt is supplied with DME, so you can have these bolts, And for this sort of template, you can make this with the metal also, and this also. The dimensions of this template is in drawing. So either you directly share that drawing with the civil so that they can make this template and make this plain structure, or you can construct that template by wood or some metal. I will recommend metal, any metal sheet, but this, if nothing is there, then this is only jugaad, nothing else. Wood. So on that, as you can see, these are the fuse bolts. What fuse bolts are there? Actually, these are anchor bolts. These are called anchor bolts. So these anchor bolts and this small one are fuse bolts. So these fuse bolts are fitted over these anchor bolts. Why? To make this structure frangible. These are basically frangible bolts. So this is installed with the LPDME. So that this ILS. So this has to be frangible structure. To make it frangible, these manufacturer has given this fuse bolts. So over this bolts, we will install our antenna pedestal. This is the DME antenna pedestal on the right. So we will mount these antenna pedestal over it after the plinth is done. So these are the typical DME locations, roughly as I have told this. Okay, we generally install DME in case of DVR over the counterpart itself. And in case of ILS, we will put this DME adjacent to glide path antenna. Where exactly at glide path antenna, that I will also show you. So now this the few earthings which we have to do with DMEs are earthing, or say RF surge protection related works, is generally we will put a earth pit for this equipment. So whatever equipment we are installing inside the hut, we will do a earthing for that equipment. So mast with which, like this mast. So we have to earth the body of this mast also. So for that, we have to do the earthing for that also. Not earth pit, but we have to connect this mast to the nearest earth to make it equipotential surface. So another thing, we will put a lightning arrestor on this mast also. So there is a provision of to put a lightning arrestor over here like this nowadays. So or in case of DVR, we have separate lightning arrestor over the counterpoise, which is above this DME antenna. And in case of glide path, as we already know, in case of LPDME, this glide path structure is already having one LA. So it will cover this, the LA of this lightning arrestor of this glide path mast will cover the this DME also. So this is, and one more thing is these surge protections. So this is RF surge protection. So wherever the RF cables from the antenna go inside the hut to the equipment. So basically there are total of three cables. One is feed and two are monitors. So at this locations, at the monitor end, we will put the RF surge protection devices, and we will earth the body of these RF surge protection devices to the common earthing. Sorry. Okay, so this is the typical DME installation nowadays, which we are doing. This is the antenna. This is the bottom of the antenna, as you can see. These are the four connectors. Out of these four, these three are RF connectors. This one is RF feed. This is integral monitoring 1 and integral monitoring 2. This connector is for the mast light, which is generally commonly installed at the top of this. So this is for mast light. And these are the, as you can see, these holes are for So to match those mast hole with this holes are provided in the antenna. So from the antenna, as you can see, there are basically three cables, RF cables, three RF cables. These RF cables, the feed one from which output is going, feed cable is of half inches and the monitoring cables are of quarter inches. So this will be half-inch cable, feed cable, and these monitor cable will be the quarter-inch cable. In case of Mopians, generally if this Thales DME is installed at stations, so Thales DME generally uses all three half-inch cables instead of quarter inches. So there is no such hard and fast rule that we have to use half-inch, quarter-inch only for monitoring. But generally for feed purpose, we use half-inch cable. So this is a RF cable connection. This will be from the top of the equipment rack. These cable will be coming directly from the antenna to the top of the equipment room. Along with this cable, one more cable will be there, which will be going inside into the antenna. This one will be the electrical cable. This is electrical cable for mast light only, as I've shown here. This connection will go in here. So these are the total 4 connection at the antenna only. So 3 RF and 1 for the mast light if it is installed. So if you this is the, as you can see, this is the current antenna, the latest one which is now supplied by Mopian. So it is like integrated sort of. Earlier what antenna came is with separate adapter, this type of adapter. So we can fix that adapter over the mast and then this antenna is mounted over that adapter. So this adapter gives us liberty to insert cable. This is openable. This if your station is having this old DME Maru one, then you could have seen this type of arrangement where you can open this box. This is a weatherproof box only. So we can open it and we can connect or disconnect the cables from here also. So besides this, there is one more assembly for obstruction light. Here obstruction light at the top of the equipment and top of the antenna. From obstruction light, there is a provision of one lightning arrestor, which I have told you earlier. Lightning arrestor. This is basically optional if we are already having some lightning arrestor nearby, which is covering this DME antenna. So if it is covering the DME antenna, then it is optional. You can put it or you cannot. But generally it is supplied by the manufacturer. So we installed it with this itself. So obstruction light, then lightning rod, then this DME antenna and another this adapter. This was basically the earlier version of antenna. Nowadays, I think it has been supplied with this only. So
सर हेलो
yes,
सर
go ahead.
आशुतोष हियर वो फीड जो आपने 4 बताया था इसके पहले वाला डायग्राम आपका
This one.
जहाँ 2 मॉनिटर, हाँ ये 2 मॉनिटर एक एंटीना और ये फोर्थ वन
ये मास्क लाइट के लिए
Fourth one is for this is electrical cable, AC cable
ओके फॉर मास लाइट
for mass light only.
ओके
Okay, these total 4 cables, 3 RF and 1 electrical, one is going to the antenna from the equipment.
ओके
So this is the basically assembly of obstruction light. Generally RCD install this, but at some say in future, if it goes faulty, then you can also change it or repair it. It is nothing in this, like this type of antenna. There is already a interconnecting cable from here to here. So here at the bottom of this is a female connector, and then one AC cable will be running from here to here. So we just simply, you can cut this AC cable from here and replace the mask light, and you can put it again, because this is already installed inside this antenna. So physical connection is from here to at the bottom of the antenna only. So in future, if you want to change this mask light, then you can do that also. It's very simple. But just to make sure that whenever you do this, make sure that you do the proper waterproofing at the top, because there will be chances of water seepage inside the antenna that can cause high VSWR and other problems. So just make sure if you change the mask light, then you should do the proper waterproofing of the same. So this is again the ports at the antenna bottom. So this is RF port, 3 RF port and 1 AC port for mask light. These are J2 and J3 are for monitor 1 and monitor 2, and this J1 is for feed cable. This is AC. This AC connector is little different. It will be difficult to find it in the market. So whatever is installed with the equipment, I think this is the one you have to use. Otherwise, you have to open this connector and then do the direct connections. So generally this connector which is supplied is having this A, B, C nomenclature, and as you can see, A is earth, B is neutral, C is mains. This type of connector is supplied. This is plug and rotate, and this part rotates to tighten in the female one. This is the photo which I am discussing. This is the mask light connector, and these are the RF connectors. So once what we did is we installed this antenna, we installed the mask light, we installed lightning arresters and all, and we put it in the this has been done. This entire process has been done, and the RF cable has been connected. So before connecting these cable to equipment, what we generally do is we check whether the connections and antenna is okay. Only this part I have to check from my equipment top to antenna. So generally what we do is we check the VSWR of this antenna. So for that, for VSWR, we use VNA, Vector Network Analyzer. I will share this. I will share the video of how to do this, or then you can see that. So we basically, whatever is the frequency of our DME, we will calibrate our VNA on that particular frequency, and we connect this RF port directly to the VNA, and it will check whether our VSWR of the antenna is okay or not. By okay, new tolerances given by the manufacturer is less than 2 VSWR. Generally, it comes out to be 1.5, 1.6, 1.2 also. So it has the tolerance limit they have given. So if my VSWR through VNA is coming out to be like 1.2, 3, 4, 5, 6, so I will consider that my antenna and my RF connection at the bottom of the antenna are okay. Now I can go ahead with the connection at the top and switch on the equipment. So this is the tolerance. This 2 tolerance is the current version which manufacturer has given in their manual. And this earlier they used to give, for Maru version they used to give 1.8 or something. So it's nowadays it's 2, and tolerance has been increased by the manufacturer. Earlier it was 1.8, but generally it comes out to be 1.4, 1.5, 1.6 around. So this is the antenna part, all the installation related to antenna part, antenna and RF cabling. So for RF cabling, you can see at your station also, these RF cable will be generally what RCDs do is connect these RF cable and put these RF cable inside a pipe, generally a flexible pipe, corrugated one, green color flexible pipe, and we will put straight away bring those cable inside the shelter. This is shelter, and go directly on the top of the equipment. So nothing else is there, just antenna and few these cables and the corrugated pipe for hiding these cable from weather. So inside the shelters, we have at the equipment part, we have few connections also. This I am discussing it entirely installation point of view, physical installation point of view. So once the equipment is supplied by the manufacturer, it is placed at the proper location inside the shelter. The equipment is placed at the proper location inside the shelter. So equipment is placed, and equipment come without cards. So cards are supplied separately. So cards are inserted into the equipment, but we have to make sure your equipment body is properly earthed before putting cards inside it. So make sure the equipment is being earthed first. So when it is earthed, then you can put these cards inside the equipment. So after the cards are installed inside the equipment, all the cards, there are a number of cards with the DME. You have seen this in your earlier classes also. So once the cards are there, then we will put the rest of the physical connection. After the antenna installation, the rest of the physical connection. So the other part of these RF cable, I will connect directly to the top of the equipment. All three RF cable I will put directly to the top of the equipment. And out of these three RF cable, two are monitors. So we put RF surge protector in path of both the monitors. And these RF surge protectors, we will ground these surge protectors. So this is the RF cabling at the DME top. Then RF, after that, this another, which I just told, electrical cable for mask light is also there, which will be coming along with this RF only, same pipe. So we will just put this cable and take it separate and put it in the some AC supply to switch on the mask light or switch off the mask light. So after these cables, so another these cables at the bottom of the equipment to power on our DME. So this electrical cables will be there. So I will discuss these electrical cables, where to put these electrical cables, and earthing cable as well. When the provision at the top of the equipment is given for earthing. So we will put a earth cable and directly put this earth cable to our junction box where all the common earthing are coming, so that our equipment is being earthed. So this is the basic interconnection with DME.
Sir, how many times this surge protector can protect the surge?
Yeah, it's actually very good question and very. Uh, as per my understanding, surge protectors can only work at on single time. So if say lightning strike at your location, so this RF surge will be utilized. Whenever the next lightning is there, I think I will this RF surge will not work. So I think we need to change
So
the
when it means became unserviceable, our RF path will be okay, or it will affect our path.
yeah. All the RF surge protection devices in anywhere in AC or RF or anywhere data also, they works on the principle of providing high resistance path. So when the RF surge, when no RF surge is there, then that is providing high resistance path to the earth. So basically all your RF is going through. So whenever there is lighting and there is high current, high RF surge, then this path will be grounded. So if this is
No,
gone,
I'm asking if RF surge
yeah,
protector go bad, what
mhm.
will will our RF path will work normally?
Yeah, RF path will work, but the the grounding of next surge will not be there.
Okay, okay.
So next time, if say lightning strike, then there may be chances or probability that your surge will go inside the equipment.
So how will we check if our surge protector is okay or not in
Yeah. This can be done if you see this RF, this surges. If the DME is at your station, then you can check. There is a button sort of. You can. This is GDT based basically. These RF surge protector are GDT based. So there is small GDT inside these. So you can say after some lighting, you can take out this GDT and you can check its continuity also. So, or if it is burnt or anything, then you can change the GDTs. So when the surge protectors, if you open it, you can open it even connected at the top. You need not to disconnect our monitor. You can simply, like with screwdriver, you can remove this GDT inside the surge protectors. So you can change that. But there is no such way we can judge whether this is the problem with GDT only. So if physical damage is there, if seen on the GDT tube, then you can change it. This is
Okay.
my recommendation only. This is not by O&M. You can discuss this with the O&M also, CHQ headquarter, because they have much expertise on this lightning there. Okay.
Okay.
May I know your name?
Myself Ashutosh Malik, AGM CNS,
Okay, sir. Okay,
Goa.
okay. Okay, this is the power connection. This is at the back of the equipment. It's very simple. Uh, these are the battery connections. We have two battery banks, battery 1 and battery 2, 24-volt battery banks, separate battery banks. These battery from the, if these batteries at the station are kept inside the battery room, then the cable will be running from the battery rooms to here. 4 cables total will be running from there to here, and they will be connected directly to the equipment. And this is the AC main supplied to the, this is also, as you can see, this is line, then earth, then neutral, direct plug and play. So no other connections for are there for external connections are there for DME for electrical. This is for data. There is this card behind this rack. So this is interface card for DME. So this is if you see, there are two connectors. So you can if you want to co-locate this DME with DVR, generally we co-locate with DME with DVR. So this is the co-location technique you can use. Simply put ident out, keyer out, or keyer out plus keyer out minus from DVR into these 2 points, these two, and you short these two things, and you make in the PMDT, you make DVR master and this DME slave, then your this DME will be co-located. This I am telling you for particularly for Mopian's co-location, from Mopian's DVR to Mopian's DME. For others, their keyer out may be different. So this particularly I am telling you about Mopian's only. So there, besides this, on this interface card, few external sensors can also be put. Generally, we don't put these external sensors, but if station want, they can put. This is supplied by manufacturer also, manufacturer itself. So these are the connection for this smoke sensor. If you want to put smoke sensor with this, or if you want to put the temperature sensor with this. So these are the connections you can do for on this port TP2. So these are all basic connections, right from the RF, all RF connection, then this is RF connection, then electrical for mast light connection, then battery connection, earthings, all the earthings, and your AC supply connection. These are all the connections we did for physical installation. So what I told earlier, I will show you. Wherever this DME is about to install at this station, so we generally send this LOWs for DVR and DME. So for DVR, as I told, this LOW will be shared to you, or already have shared if the installation is going on. So this DVR LOW, as I have told you, with the DVR, we generally install the DME at the top of the equipment. So top of the counterpoise. So there will not be much in the DVR LOW for DME. But for ILS, we did separately. So here you can refer page number 9 of LOW, which RCD is currently sending. Page number 9. But why I'm telling you this is, at least you have some reference when civil or some other agency asked for this. This. So page number 9. So this is written for LPDME Mask Foundation. So for wherever this DME is installed, I mean LPDME is installed with the ILS. So you have to refer this drawing. I will show you this drawing also. So this will give you the exact location where you have to put your DME antenna mast, and this plinth, size of this plinth, whatever the plinth is there, the size of the plinth will be like this: 2 feet by 2 feet by 3 feet. This is length, breadth, and height. So this you can refer for if you want to refer the LOW. This is our RCDO doc. If if people are not aware with LOW, this is basically list of work sent by RCDU to the stations where this installation are about to happen. Or so another this page on page 30, you will find this drawing. This is the page 30. Yes. Yeah. This is a typical layout. Find this. These drawings are shared. Yeah. This is layout drawing of glide path site. This is the entire glide path site, but here you can see this is our glide path mast. This one is our glide path mast, and this DME mast is here. So you can see we have to make, this is 3 meters. So this DME mast will be 3 meter laterally away from the glide path mast. So this is center of the glide path mast, and this is center of the DME mast. And we generally put the glide path mast little, this DME mast little behind the glide path mast. We have to make sure that this DME will not go above the glide path mast. And next question will be where to put this. I mean, we can put this DME mast on this side also or this side also. So we have to put it away from the runway only. Always we have to put this DME mast away from the runway. So this is, you can refer this drawing for the same. Nothing else is there. So now for the slide which I showed you, this one, on fewer occasions when civil is doing this work, then they can ask how to, sir, kaise install karna hai, how to install this. So it has been given in our drawing also. So you can say civil people, please refer this drawing. This is basically the mass drawing. The template is designed on the basis of this. So this is supplied by RCDU. So you can make these whole, this template can be designed using this drawing. So as you can see, this is the front view, and this is the top view of the plinth. And these are the gaia wire. We are not currently using this with our structure. We are just using this center one. We are not using these gaia wire for DME. So it has been supplied, but we are not using. Also, here you can see there are three portion of this mast. 1, 2, 3. So also in case of LPDME, we don't use this middle section. We use only this one section, this bottom one and this top one only. So only two section we use generally. Because of height, this is too much height, already 7.5. Here you can see already 7.5 meters. So it's too much height. So, and so this is the important thing. You can refer in the future also. And for the depth and how much these, okay, how much depth should be these planes should be made, and how to concrete them, and XYZ. These for these type of question, this is the reference drawing. Here you can see this plinth, how much should be the footing of the plinth, how much should be the concrete, and how deep should these your anchor bolt go inside the plinth. So each and every height is given in these drawings. So because generally the civil people make these planes by themselves. I mean, they guessed it the same they were doing earlier, and they made the same as it is. As this mast is heavy, I think the station has to make sure that the plinth are designed as per their drawing only, because these masts are extremely heavy. So this is not a very light mast. Okay, this is basically the installation and the cable testing part of this. So I will play a video which we discussed last in DVR training also. So sir has also requested to play this video. I have arranged that video. I will play it now. Then after that, we can discuss any questions for today. Then
to make a connector. Piyush?
Uh,
Yes, man. It's audible here. Audio.
is it audible to all?
Yes, Piyush.
Okay, okay, sir.
Connector and a half-inch cable. So these are the tools required. First, hacksaw, then nose pliers. We'll be using file, then spanner, 20 mm and 19 mm ratchet, then a knife, bearing tool, and a stripping tool. Broken box of connector, we get a cable entry, cable head, connector head, O-ring, and ring O-ring. This is a standard half-inch corrugated cable. We'll be making a connector on it, and the first step is to cut it perpendicular to the axis of. After cutting, the end result will be this. You can see it is cut exactly at that rough. Go. Next step is to strip the cable with using this stripping. After stripping the cable, this will be the end result. You can see the outer jacket is removed. Cable is cut exactly at the crest. Now we'll add O-ring. First we'll add cleat. This is for weatherproofing. Now we'll add O-ring. Then we'll add cable entry. After that, spring ring. After that, we need to flare this outer jacket. We'll use this flaring tool for that. You can see how it fits exactly between the outer conductor and the dielectric. Slowly rotate it. This will be the end result flaring. You can see how smoothly this flaring tool flares it. Oh. Now we'll add a connector head. You can hear this clear now when this moves in. Oh. After adding this connector head, we have to tighten it. We'll use a 2123. We'll need a 2123 spanner. Actually, we'll be needing 21 mm, a 19 mm ratchet.
Mayank, audio is gone. I think you. Mayank, unmute yourself.
Uh, this is how to make a RF connector. And once this connector has been made with cable has been made, we can test these cable for their lengths, electrical lengths through VNA. For that, can refer from here.
Net to test cable. I'll play that video. Objective of this view say to measure electrical length and test it. For that, we will need calibration tool of VNA. It is supplied with Anritsu VNA, extender cable, and VNA. This is VNA model MS2035B. This is the main connection part of it. There is port 1 and port 2, which we will be using while testing it. And moving on to keypad. Here we have a keypad from where we can enter frequency, change modes. We'll see it later. Now we'll switch it on. After switching on, this will be the main page. If right now it is in vector voltmeter mode, but if you if you have used it earlier, it is possible it will in mode first. So in that case, you'll have to change the mode. Here, from here, you can change the mode. Press shift, then mode. This window will pop up. From here, you will select vector voltmeter. You can use these navigation keys and or this rotary button. Press enter. Now it will come in vector voltmeter mode. Now we have to change frequency. Press this tab. Then you will have to insert frequency. Use this number pad to enter frequency. Suppose you want 120 megahertz. You can see here frequency. After setting frequency, you have to calibrate VNA on that frequency. For that, you can press shift, calibrate. Now we have to start. Now you have to choose which type of calibration you want to do. From here, we will choose S11, that is single port calibration, because we will not be using the second port in our objective. So here we will select single port. Now we'll start with calibration. This window will pop up and you have to follow the steps now. So the steps say connect cal component, select step, press enter. So you have to connect open port to port number 1. I have extended this port 1. Now we will connect open port here and press enter. Now it says connect short. Now I will connect short. Press enter. Next step is connect load. Connect load. Press enter. Now calculate and finish. You can see calibration is on and okay. Now remove the calibration tool. Now we'll touch this CW tab. Here you can see the measurement type and measurement format. So when we have to measure electrical length, we'll select this dB. And when we'll be measuring VSWR to check this cable, we'll use VSWR tab. Now we'll connect this cable. You can see the electrical length is 126.7 degree and loss is minus 0.90 dB. If you want to test the cable, we'll select measurement format as VSWR. And to confirm it, we'll add a dummy load. You can see the VSWR is 1.04, and from here you can say the cable is what. Times you will see calibration on, but in bracket you will see a T mentioned there, or whatever it is except OK, you should recalibrate it. Otherwise, the readings are not reliable.
Uh, okay, so this is the way to make cable and test these cables. So at there may be chances at station that the cable is damaged or something, then you can make these cable, and with the use of VNA you can test the antenna and cable also. So this the portion where at the end of this VNA thing, he attached a dummy load to check the VSWR. So if I connect directly antenna, so it will give the VSWR of the antenna. So like in the video, this calibration was done at around 120 megahertz frequency. That is for localizer, around localizer frequencies. So for DME, we will calibrate it on the proper transmitting frequency, which is around 1000 megahertz. So whatever is the frequency, and we will calibrate our VNA on that particular frequency, and we will connect the cable directly to the antenna and other to the port 1 and check the VSWR of the antenna, which in turns will come out to be less than 2 or 1.8 or something. So this is this is what I planned for today. Because if I start the thing like it will get late. So you can ask question. We will start. I will start this switching on equipment and optimization or whatever calibration. I will cover it tomorrow. So it's very small portion. I have this application I have installed directly. So I will share this detail right from here. Instead of PPT, I will share directly from here, this PMDT. So until now, all the physical connections and all the things have been checked. AC, DC, RF, earthing, surge, everything has been connected. Now we will ready to switch on the equipment. So the importance of checking this VSWR is very much. This is the reason because, like, if say something is wrong in the sense that if I have not connected my RF cable properly, or I have connected in the wrong connector, or it is little loose, so this port will be open. And like as we know, in case of this HPDME, the RF power is very large, like 1 kilowatt. So it is very much chances that if these ports are open or something, then my equipment get damaged. Definitely the PA will be damaged. So this is the practice we follow, and I think which is very good practice. So before switching on the power, we have to check the entire path from the top to the antenna, whether we have connection all are correct and right. So स्वर्णकार सर, आज बस इतना ही रखते हैं. कुछ क्वेश्चंस हैं आज के लिए पूछ लेते हैं, बाकी फिर कल कवर कर लेंगे.
Thank you, Piyush. Actually, sorry for the late session. There was some problem at RHQ. People were on leave, and after a long coordination, finally the meeting started. Thanks for the patience. Especially you have waited for long.
नो इशू सर. एक्चुअली दिस इसमें पोर्शन इतना ज्यादा है भी नहीं डीएमई का फॉर आरसीडी पॉइंट ऑफ व्यू. So मैं यही सोचा था फिजिकल पूरा जैसे आज कराकर और कल फिर हम इसे ऑन
Yes, it
करके
was nice to see all the connections which you have shown, all RF feed, monitor antenna feed, how electrical cabling has been done, how it is to be earthing, and those points are really very useful from station point of view. Now, that especially your presentation on VNA also, and how we are making those connectors will be very helpful for all of us. I hope this is sufficient for today. What is the plan for tomorrow?
Sir, tomorrow, basically, I will, मतलब, from energizing equipment to the calibration, I will cover. And I will cover it directly from the app because in this, the PMDT, they have given this offline demo mode. So
Okay.
there is no need of PPT. I will show you directly from here. So
Okay.
he has given demo application also. So this is
Sure.
yeah, direct.
That will be very useful for all
That is
of
very
us.
useful. It will be very clear. DME, I don't think there will be any, problem with
Sure.
DME. It's very simple.
Sure. I hope the participants must have uh, learned whatever Piyush has informed us. And tomorrow will also be a very nice session from RCDU team. Kindly do join, all of you. Thank
Any
you.
question for today, you can ask.
Participants, any questions, please? Please raise. सर किसी को डाउट है?
No issue, sir. Okay.
Piyush, we will carry on tomorrow then.
Okay, sir. Okay, sir. Okay,
Okay.
thank you.
We will meet at 3 sharp then.
Okay.
Okay. Thank you. Thank you so much. GM sir has also called me and has extended your um, welcome. He told
Okay,
that
sir.
today he was unable to join because of meeting going on there. Uh,
Okay, sir.
thanks from his side also. Thank you.
Okay, sir. Thank you.
Okay.